For lesson 7 on step functions, we want to talk about how we make all of our horizontal and vertical lines on a graph. So we'll start with our x equals lines, which are our vertical lines. So anything that's x equals is going to be vertical. So we go over 1, 2, 3, -4, and this is going to be our x equals -4 line. All right, it's vertical, it goes through the point x equals -4. So then 1, 2, 3, this is going to be x equals +3. Again, another vertical line. So we'll go over to our y equals now, and those are going to be our horizontal line. So we go down 1, 2, that's y equals -2. And then we'll go up 2 from the origin, and that's y equals +2. So again, x equals is vertical and y equals is horizontal. So then if we want to find our area here, we need to count. Well, we have a height of 4 and a length of 1, 2, 3, 4, 5, 6, 7. So then our area is going to be 7 times 4, which is going to be 28, and we'll just go units squared, since we haven't been given inches or feet or anything like that. So now if we go to a word problem, as we saw in the lesson, the postage rate on the envelope is a great example of a step function. There is a fixed price for a certain range of weights, then another fixed price for another range of weights, and so on. Below is the graph for one such price structure. According to the graph, what is the rate for a letter weighing 1.5 ounces? So if we go to 1.5 on our graph for our ounces, and we go up, we find that it intersects our graph at that second horizontal step. So if we look at our y-axis here, it's 50, and then there's 1, 2, 3, 4. So it takes 5 lines to get to $1. So each of those lines is going to represent 10 cents. So if we go over, that's going to mean that 1.5 ounces is going to be 70 cents. What would be the postage rate on a letter weighing exactly 3 ounces? Well, this one becomes a little bit harder because we go up and we should see that it hits both a closed circle and an open circle. Now remember, at the open circle, that doesn't actually exist. So we need to only account for that closed circle, and as we go across there, it looks like it's above that line, and it looks like maybe it's about halfway through. So therefore, I'm going to guess that it's right around $1.15, because as you can see, that dot falls, it looks like, above the $1.10 line. We'll say it's about halfway, so therefore we'll call it $1.15. Would it be correct to state that the range of this function is 50 cents, less than or equal to y, less than or equal to $1.15? And the answer is no. When you write something that looks like this, it means it includes everything in between those two numbers. Well, if you look at our step function, there is no line at 60 cents. There's no line at 80 cents. So all of those weights are not included. There are very specific ones at 50, 70, 90, then we got $1.15, but it does not include all of the numbers in between. So you can't write your range like that as an inequality because it does not include everything in between. So you got to be careful. For step functions, they only include specific numbers. So your range would literally just be those specific numbers, and you can't write it as an inequality because it does not include all of the numbers in between.